Hi, this is just a short video about these wee beasties. If you can see those, field effect transistors. I don't know much about these are just a few little bits I found out about them. If you got some second-hand ones or you got some units in a piece of equipment and it's not working, do you know whether these are any good or not? So I just thought I'd like to share these little bits of information. It's just a few insights, and I was quite surprised at how simple this little operation was. So I took the numbers from the FET, and here we go. Here's the data sheet. Now there's loads of stuff on here that, I don't know, doesn't mean much to me, but the main thing is here we've got gate, drain and source. Well, the gate is the switch, the source is where the power's coming from, and the drain is where it's going to. Now I'm assuming these are an N channel. I haven't actually found anywhere on here that it means, but there's an N in there in the number, so it's an N channel, which means it switches the negative. The main things are it'll switch 20 amps, maximum of 650 volts, and the internal resistance is 0.19 of an ohm, which is reasonably large. There are other FETs with 0.03, which is a lot less, and the more resistance you've got, the warmer it's going to get. The other thing that's important here, we've got continuous drain current, 20, which is fine, but there was something else on here. Gate source voltage static, plus or minus 20, so 20 volts maximum to switch it on. But if you only put, say, 3 volts in, it'll only switch on halfway, and when they're only halfway they'll get hot. So let's have a little experiment. Before the experiment, I really must point this out. On this little drawing here, you won't be able to see it, but it shows 1, 2, 3. Now on this drawing here, gate is pin 1, drain is pin 2, source is pin 3. So I've written that down, gate, drain, source. So on this FET, with the heatsink at the back, gate, drain, source, and the drain in these ones is the same as that, so those are connected. So here's one of those FETs. That's the 20N60C3. Gate, drain, source. So negative goes to the source of all power. That fiddling wire is a bit awkward. Then the load, which then goes back to positive, goes to the drain, which we could also connect to the heatsink on the back on this particular one. And then, well, these test leads got a bit burnt yesterday when we were at the watermill. Positive onto the gate, it's on. There you go. Negative onto the gate, it's off. That seems to work. Put the finger on the positive. We're only switching 12 volts here. And just finger on there. It's sort of, see how if you only give it a little bit, it's only half on. And it's when it's half on that it's resisting the flow of current. And that's when they'll get very warm. So that one's alright. And you can just test them like this. And you go, that's alright. Now then, here's another one. This is the other type, another type, which is an IXF 34N80, which is 800 volts, 20 amps continuous, gate drain source, but it's got 0.24 of an ohm. So this has got quite a high resistance. So drain is the middle. You won't be able to see what I'm doing. Source is there. Drain is there. Ah! So let's just clip that on there. So it's come on straight away without operating the gate. Let's see if we can put negative to the gate. Makes no difference. So that FET has had it, and more than often than not, when they burn out or go or don't work anymore, they go short circuit. So that one is duff. I've got another IX what's it here. Here we go. So negative onto the source. Tell you what we'll do. Let's put the drain onto the heatsink on the back, just to show you. Positive into the gate. There it is. Switch it off. Let's move it forward a bit. Positive into the gate. There. Switch it off. Touch that. That's half on. Switch it. That's off. That one seems to be alright. If this was working and it got really hot with only that 3 amp load, like you can't touch it after 30 seconds, throw it out because it's on its way out. I just thought I'd like to share that with you. Hope you enjoyed it.